Okay, this is 7.3. This is mostly factoring. However, one of your classmates said that I should have told a joke or something to make it a little more entertaining. Therefore, for the next about 20 seconds, ideally, there's going to be some pictures coming in if I can figure out the video correctly. Yesterday, I got to take my girlfriend, Ari, to the hospital because she cut her finger. And what was really funny is that I got to sit in the exam room, and I thought it was a very inappropriate time to start taking selfies, which is something I never do. So I took some hospital selfies, and if you guys take a look at her face, she is not very happy that I'm doing that. So yeah, cool. Anywho, moving on to factoring. First, I want to talk about box multiplication. Okay, yesterday or the other day we were talking about distributive property in which we can use distributive property to say x times x and then x times 7, and then we'll come in with our other color and we'll say 2 times x, 2 times negative 7, and then we add all the pieces together. You guys like to call this FOIL. I hate that word. I like to call it distributive property. Today I want to show you another method called box method, in which I saw some of you guys doing actually. So what you do is you set up a box and you put the dimensions on the outside of the box. And for how many pieces you have, you draw lines. So for this plus sign, I'll put a line here. On the other side, I'm going to have x minus 7. So again, I drew another line. I'm really big on geometry, and these quadratic equations, they're actually very geometric. And what's actually going on here is we can do area multiplications to actually solve the entire multiplication. So we just have to look at areas of little boxes right now. And if we remember, the area of a square, okay, is if a square has side s and s, then the area of this square is s squared. Okay, so, or if you have a rectangle, okay, the area of the rectangle is length times width. So we're going to use this idea to actually multiply these binomials. So x times x is x squared. This has a length of x right here, x, so 2x is this box. This box down here has, this side is length x, this side is negative 7, so this is negative 7x. And then this box over here is negative 7 in this dimension and 2 in this dimension, so this is negative 14. We can now take all the pieces and we can actually claim that x plus 2 times x minus 7 equals, we're just going to add up all the pieces. So x squared plus 2x minus 7x minus 14, which brings us to the total of x squared minus 5x minus 14. Which, if you had done this distributive property up above, that's exactly what you would have gotten. So these are really cool and actually really nifty for if you have a component of 3, if you have a trinomial being multiplied. So maybe you have x squared plus x plus 2, and then maybe you're doing x plus 2 over here. You can actually use the same method, and you can fill out all the areas, add them all up. So in general, this box multiplication is the product of the dimensions, the product being the multiplication of the dimensions is equal to the sum, or the addition, of adding up all the pieces. Next, I'm going to go over a factoring technique And we call this factoring technique called splitting the middle term. And these are the steps. You should write these steps down right now. Pause and write the steps down. So, splitting the middle term. This is how it works. When you have a quadratic such as ax plus bx, or ax squared plus bx plus c, we'll take this, and the first step says multiply a and c. What you need to remember that if you don't see anything in front of this last coefficient, or sorry, if this last variable, there is the coefficient of 1. So this is all negative 1, okay? Negative 1. So we're going to multiply AC. That is our first step. So 10 times negative 1 equals negative 10. Second step, we're looking for two factors that sum, that means add, okay? And then to B, and the product or the multiplication is equal to AC. Okay, so what we're looking for is we're looking for two things that add to negative 10, and the same two things need to multiply to negative 10. And this is the hardest part. This is the part that requires the most thinking. For this one, so let's see. I have to, oh, I'm sorry, not negative 10. Blowing it. 3. The middle term, B. Okay? Needs to add to 3. I'm sorry about that. Fix that in your notes. Okay, so looking at this now. You need to find two numbers that add to 3 and multiply to negative 10. Okay? So, since I'm done this a little bit, okay, the first things that come to mind of how to get negative 10 or 10 in general is 5 and 2. I'm lucky enough to know that 5 and 2 go into 3 also. So, let's see. I can say 5 plus negative 2 equals 3, and 5 times negative 2 equals negative 10. Awesome. Now, I'm going to go back to my original equation. I'm going to write 10x squared. Okay? But now, instead of writing 3xy, what I'm going to write is I'm going to say I have 5xy minus 2xy. I have used my two terms here, 5 and negative 2, in splitting the middle term. I have turned 3 into 5 and negative 2. And then continuing out, minus y squared. Okay, we have split the middle term. Now what we need to do is we need to look at this new equation. And we need to undistribute, okay? Or we need to pull out greatest common factors. The best thing to do is to identify this as two different equations. I like to look at this first, followed by these. And I'm looking for common greatest factor. So on the first one, the greatest common factor is both terms have some multiple of 5. So I'm going to pull out a 5. They also have a multiple of x. Each term has an x in it. So I'll pull out a 5x. Okay. What was left then would be 2x plus y. Okay. Looking over here, it looks like I can pull out a negative 1 because there's a negative in both. There's also a y in both. So I'll pull out a negative y, which will give us 2x plus y. Okay? Now, I'm one step away. What I need to realize is that I have the same binomial right here, 2x plus y, so that is one of them. Okay? So really what I have is 5x minus y. I'm going to take those two pieces times 2x plus y. And that is actually our answer at the end. We can check this to verify that we are correct. So 5x minus y, 2x plus y. Let's go box method. Why not? So 5x minus y and 2x plus y. The area of this box right here is 10x squared. The area of this box is negative 2xy. The area of this box down in the left corner is 5xy. And then the area of the box on the right is negative y squared. Add this all together, I'm going to have 10x squared plus 3xy minus y squared. Awesome. Okay, so that was quick. Let's go ahead and do just one more. I'm going to go ahead and throw up the factor of 2x minus 4x, 2x squared minus 4x minus 70. Okay, first thing we do is we multiply a and c. So 2 times negative 70 equals negative 140. In my second step, I'm going to find two terms that add to b, which is negative 4. Okay, and I'm going to find two terms that multiply to negative 140. Okay, I immediately go to this number right here and I start thinking, what are two numbers that multiply to 140? There's 70 and 2. There's, I don't know, 35 and something. Let's see, but my favorite, or the easiest I think of, since I have a 0 here, I'm thinking some multiple of 10. So I wanted to check that one first. And I'm actually thinking negative 14 and 10 will work. 14 and 10 will work. 14 and negative 10 will work. But 14 and 10 won't give me a negative, so I can cross that out. So it has to be one of these combinations. And do these add to negative 4? Well, yeah, if I'm clever about it, they do. So what I can put is that I have negative 14, okay, and 10. That will add to negative 4. And it also, negative 14 and 10 will multiply to negative 140. Okay, so again, we're looking for two factors, okay, two factors that sum to b, or sum to negative 4, and multiply to AC, which was negative 140. Okay, in step 3, we are going to split our terms. So now we have 2x squared minus 14x plus 10x minus 70. Once again, I'm going to split this into two pieces. I'm going to look to see if I can pull out any common greatest factors. Okay, any common greatest factors. Well, let's see. 14 is a multiple of 2. 2 is a multiple of 2. I can pull out a 2. Each factor also has an x, so I'll pull out an x. 2x times what is left, x minus 7. What can I pull out on the other one? On the red box, I can pull out, it looks like I can pull out a 10. 10 goes into 10 and 10 goes into 70. So I'll pull out just a 10. And it looks like I have x minus 7 again, which is good. If these two don't match, it means we're doing something incorrect and we need to go back and re-examine our last step. Let's combine this together. This gives us 2x plus 10 times x minus 7. And this is our final answer. That is our factored form. Okay, so this factoring technique is called splitting the middle term. Let me know if this worked for you guys. Questions, comments, anything I missed, anything that you need explained more, just let me know and I will help you out. Thanks.